accident on December 7th, January 3rd, and January 4th.
Heavens, guys. Oh my gosh. How's it going, guys? Welcome back. And today we're going to be looking at the 737 MAX door blowout issue, if you will. And I am a mechanical engineer, private pilot, and I like 3D printing. So two of those I'm somewhat qualified to talk on this, I guess, and give my perspective and point of view, and maybe help dissect something, or I don't know, just learn something new. I'm interested in learning things, and I hope you guys are too. And if you are, I think you'll like my content and what I bring to the table. So yeah, let's just jump right in.
This video is brought to you by Nebula. Get 40% off our yearly subscription by clicking the link in the description. After another headline news accident, the 737 MAX feels like a cursed plane.
So if you remember, before he might talk about it, I don't know. The 737 MAX, I believe it was something with the autopilot, and basically it fighting the pilot, overriding the pilot and crashing. So I believe that was 3-4 years ago, or more. I remember because I was in material science in college, which was like end of sophomore or beginning of junior year. And my professor, he was like, I mean, I agree with him. He would say the amount of flights that the 737 MAX program had done so far, he would still get on one just because of, one little issue. I agree. I mean, air travel is so much safer than driving in your car. Statistically, you're higher likelihood of dying on the way to the airport than going from airport to airport. So, yeah.
On the 5th of January 2024, the plane suffered yet another incident when a door plug in the fuselage of the plane ripped off at 16,000 feet.
Luckily, nobody got sucked out. But I did see an iPhone, was it 15 or 16,000 feet, he said? An iPhone actually survived the fall. So that's interesting. I saw that headline.
The force of decompression in the fuselage of the plane ripped off at 16,000 feet.
16,000 feet.
The force of decompression reportedly ripped the shirt off a child's back and slammed the locked cockpit door open. Searches for...
Wow. That's pretty impressive. I was actually looking up ahead of this. I found this article because I was curious how much pressure was on the door itself, and it's actually a lot more than you would think. So I found this one, and I think the math checks out pretty good on this. So he talks in depth about some things, yada, yada, yada. And then looking at about 16,000 feet, goes through some math here. And so basically the differential pressure between outside air temperature at outside air pressure at 16,000 feet and the interior cabin pressure, that differential pressure, then we can take the area of the door, and then you can calculate your total load on the door. So pretty handy. And what he kind of just guesstimated here, which I think is kind of really the only way you can do it right here, is guesstimation, is zoom in here so you guys can see it. So he's estimating the door to be 3 foot by 5 foot. That makes sense. People can get out about 5 foot, 3 foot wide. That seems about right. So 15 square feet, multiply that all out, yada, yada, yada. So about 4 tons, basically basically a F-250 diesel. I think that's a little over 7,000 pounds. So almost 8,000 pounds. So that's quite a significant load just sitting on that door. So you can see why some missing bolts would be somewhat important. And I'm curious where this goes as far as Boeing's quality assurance, as far as what was missed, I guess. That's what I'm interested in, because I do work fairly closely with manufacturing, and we have certain work instructions, follow steps, inspect at this step, make sure this is here and in this done this way, etc., etc. So I'm curious where that could have gone wrong.
For the missing door plug over the weekend only turned up iPhones, which somehow survived the fall to the streets of Portland below. Thankfully, none of the 171 passengers or 6 crew members on board were seriously injured, in part because the seats directly next to the damaged fuselage were empty. After cabin...
Ooh, that was lucky. I do. My grandpa is a private jet pilot. He's been doing that for about 15 years, and that's he started training me, so that's where I got my kind of want to be a pilot. Anyhow, he would tell me that his procedures for depressurization. So a window blows out in their jet and they're at 40-some thousand feet. Well, you would drop, I think I read on another article, something like there's about a 7 to 8 psi differential pressure. So even more than the 16,000 feet, that would probably be, he calculated, I forget what he calculated. I don't want to misquote it. But anyhow, it would blow out, and basically you'd have about 30 seconds of consciousness because the air's so thin up there. And so he'd basically have 20 to 30 seconds to get his mask on to get oxygen to continue flying the plane. And basically he said you just pull your engines all back, full flaps, full air brakes, probably drop the landing gear too to just dump as much drag out as possible, and then nose it down until you get down to probably, well, as low as you can to land as quickly as you can. But at least for the passenger's sake, you need to get under like 14,000 to really be able to reliably breathe. As like a pilot, like from that's commercial. So if I was a recreational pilot, let's say, which I am, and wanted to go somewhere and I wanted to go up higher, I believe the FAA rule is around 14,000 feet, 14.5. Maybe it's 13.5 that the pilot is supposed to wear oxygen. It's right around in there. I'll throw it up on screen. Don't remember it exactly. But basically the pilot has to have the oxygen before the passengers, more or less, which makes sense, obviously. So, yeah.
Pressure was lost, the pilots dropped in altitude and returned for an emergency landing. So what exactly happened? How could an entire panel of an aircraft just rip off?
Door plug blowout. So I'm curious if that was like a chain reaction, like something else blew out and then the door went.
Like this. To get some clues, let's first see what the hell a door plug even is. Door plugs are essentially structural and cosmetic covers for empty door frames. They are options for the 737-9 plane when an airline is purchasing the aircraft. If the customer wants a higher maximum occupancy, they can take the option to have a functional door installed in this door frame. This is because the number of passengers allowed in an aircraft is linked to how many emergency exits there are. If they chose for a lower occupancy, they can opt for a door plug, as Alaska Airways did. The door plug is not a functional door. It, as the name would suggest, simply plugs the doorway with a door-shaped plug. You can tell them apart from the outside as they have full-sized windows, where actual doors have smaller windows. On the inside of the plane, you can't tell that the door frame is there, as the panels look the same as any other panel. This allows a standard row of seats to be installed in this location. Deactivating this exit reduces the max occupancy of the 737-9 from 230 people to 189. If an airline later decides to increase the occupancy and operate more like a budget airline, like say Ryanair, where seats are placed closer together, they can later install a fully functional door in this location. It was this door plug that ripped out of the plane, and the photos of the aftermath are quite confusing. There was remarkably little damage to the plane. These are stop pads, and they are designed to take the load of pressurization from the cabin pressure, interfacing with the stop fittings on the door plug. Had the door been truly blown off, you would expect these to be damaged, but they look very much intact. Down.
So I'm guessing just from this, it sounds like there wasn't enough bolts in and just sheared the bolts, maybe stripped the threads. I don't know, just a guess, we'll see.
Here are hinges and straps that allow the door to open at about 15 degrees during maintenance. And at the top and bottom corners of the door plug are guide track roller pins that slide into guide tracks in the door frame before being secured in place by locking bolts, one in each guide track. For the door to open, it would have to move downwards past these locking bolts. The door was found on Monday, 3 days after the incident, and it too seems to be in remarkably good shape. This to me suggests that either the fasteners attaching the plug to the aircraft fractured or they were improperly installed. Perhaps.
I want to go back to this because I'm not sure I fully understand this. So he's saying the door plug and track. Where's that at? Door plug and track. I wonder if that is. Let's get our hinges. I wonder if it's this piece right here. Upper guide fitting, maybe. I don't know. Maybe it'll come along a little later.
The plug to the aircraft fractured, or they were improperly installed. Perhaps the incorrect bolt was used, they were under-tightened, or missing altogether. And indeed, early reports from industry insiders at United and Alaska Airlines are stating that they have found improperly tightened fasteners on several aircraft, which would make a lot of sense for how
Naughty.
clean the brakes look. So, who's at fault here? It's of course too early to give a definitive answer, but the blame could well be spread across multiple parties. Boeing does not manufacture these parts themselves. Their subcontractor, Spirit Aerosystems, manufacture both the fuselages and door plugs in Wichita, Kansas, before delivering them by train for final assembly in Seattle, Washington. The door plugs are usually not rigidly installed in this step because Boeing removes them to install interiors for the final customer, and then fully secure the door plugs during reinstallation. This seems like the type of thing that could potentially get lost in communication between two separate companies. Perhaps in some cases the door plugs were never removed for this purpose, and whoever was in charge of reinstalling the doors was not aware that they were delivered in the semi-complete state. That's my working theory, but again, it's far too early to state anything with confidence.
Yeah, so this reminds me of it's called poka-yoke. That's a kind of a saying. It's I believe it's Japanese based. It has to do with manufacturing, basically making something go together that it can only go together one way. I don't have a good example off the bat, but it would be like, okay, so you got your screwdriver here, lttstore.com. My dog chewed the end of it, but so it'd be similar to like having, let's say you got a part and then you got only one part fits into that recess or whatever. And then say shift change happens and you have a different part, and say you key this part a certain way or key this opening a certain way where this would not be able to fit in. So that'd be basically one part can only fit in this, can be paired with this other piece. You could do that with orientation, so on and so forth. So that's something you got to think about, because you have to make stuff basically stupid proof, because crap happens and half the time people assembling stuff don't really care. They're just there for a paycheck and they're just doing stuff all day, and I don't blame them. Stuff gets monotonous and stuff can happen. So making it basically idiot proof is a big deal in manufacturing. And so if you're an engineer, and especially a young engineer, and working on things of that nature, just try to figure out the ways it could be messed up very easily, even if it's like, how could you mess it up like that? And it can happen. So just try to make it, the design kind of starts from the beginning. You got to start your design like, well, how could this? Design is such a big spectrum of things you have to consider, because if you want, you got to design it for cost. So you got to make it, well, we got to use standard XYZ. We got to make it easy for the machinist to do XYZ. We got to make it low cost. Yeah. So you got to make it easy to make, easy to procure, and easy to assemble, manufacture, and then make it repeatable. And so there's a lot of factors, and I'm just grazing the surface, because that gets all involved in like tolerance stack ups. And I think a good example of like a machinist thing would be like, say you have an aluminum part. I'll just use my phone for example. You have this radius. We'll use the inside of the radius here. So the inside of this, if you make that like a non-standard drill bit, so like a quarter inch drill bit would be that'd be 1/8 inch diameter, or 8th inch radius. So you could put an 1/8 inch fillet in here and still use a 1/4 inch end mill, and then just trace that path. If you make, say, 100 thou radius, the machinist would have to rough it, and then you'd have to get a smaller bit to go in and make that. So then that's an extra operation for your CNC guy, extra money into your part. So if you reduce things like that in your part, that can help quite a bit. So, all right, we'll beat this dead horse. Let's keep going.
This is just me employing Murphy's Law. If something can go wrong, it will go wrong.
Going back to the poka-yoke, making it idiot proof.
Or perhaps someone somehow managed to not fully secure the bolts across multiple planes.
Maybe they put it in halfway and clock out, time to clock out, let's go home. And then they're like, and they just forgot. Or maybe they got fired, or who knows. Any myriad of things could happen.
That seems less likely to me. Boeing pressurizes the hulls to 150% of typical air pressure before delivering the plane as a safety check. So, in theory,
That's another thing too, because they do system level testing, of, like I just said. So why wouldn't it fail then? That should really blow it out. So this has to be something where it's cyclical, similar to the Titan sub, which I did a video about that. That'll be in one of these corners. You can go watch that. And so cyclical loading, think of your mattress. You get on your mattress over 10 years, you got a little divot in it, right? Or maybe you got a Tempur-Pedic, and that doesn't really do it. But after a certain amount of time, it's going to have a divot in it, right? So you have that hull being pressurized and then depressure, stuff moves. The strain on the bolt, gets loaded and then unloaded, loaded and then unloaded. Stuff works itself loose, strips threads, what have you. I think that's the direction this is going.
this could have alerted them to improperly sealed door plugs. However, air pressure pushes the door plug against the door stops.
Oh, yeah, I didn't think about that. So that's working in its favor then. So that makes it really interesting then. So, it still must be moving around somehow because of the cyclical loading. Because the whole airframe, like a submarine that goes down, and you've seen in maybe the submarine movie, the string they put across, and as they keep going deeper, the string starts to droop because the hull's getting crushed. So it's getting stretched. I think it still goes back to that cyclical. It's moving around, and maybe it slides off the peg. One goes, and then it all goes.
And the semi-installed bolts could have held it in place during the test. But bolts can vibrate loose.
Plus, yeah, and cyclical and the vibration involved. If you've ever been on a plane, it can be highly vibratory. That's a word.
Over time, especially if they are not installed correctly. That's why this wire tie is installed. It's designed to stop the fastener from rotating loose.
Castle nut, yep. With loose door source, the door plugs lower hinge bracket. That two screws are not screwed in all the way. I wonder if these are it right here. The two. That's the only place two screws are, I guess. Looks like there's maybe two more on the backside.
Is
this on the hinge? With loose door plugs, lower hinge bracket. So maybe it's the hinge that gave way, and then it just kind of slid off the supporting tabs. Just slid off, and then you're going.
A lot of different methods for doing this, like locking washers and adhesives. Some blame could also lay with Alaska
Adhesives? I think it means adhesives.
Airlines. The initial National Transport Safety Report stated that exact airplane had 3 previous pressurization issues where the pilots had to take action, all in close proximity.
Nice. It's probably leaking.
To this accident on December 7th, January 3rd, and January 4th.
Heavens, guys. Oh my gosh. Oh. Some might say statistically significant. It's like December 7th, then less than a month later, the 3rd, and then the next day, the 4th, have the same issue. Bing, bang, bang. Come on, guys.
And reportedly, the maintenance crew simply reset the pressure warning lights and system without performing any checks for pressure leaks.
There's checklists for a reason, unless they were, instructed incorrectly. That's no bueno. That's not how you should go. Especially with that many events. And I don't know what the flow of a troubleshooting checklist would look like. I have great respect for A&Ps and, you know, all the knowledge they have. So, but people make mistakes, and or I don't know. Curious. Let's keep going. I could speculate all day.
which could have been caused by this faulty door plug. Alaska Airlines knew there was an issue with this plane and
True. So with root cause failure analysis, whatever we're going to call it, you can really get into assumptions, but you really have to step back and list all the possible things that could go wrong. It could be a faulty sensor, you know, it could be, and the door could have been fine the whole time. And those two items can be separate. They don't have to be together. So the door blowing out could be separate from the pressurization issue. Although it seems unlikely, it is possible. I've seen circumstances like that in my job where I'm like, oh, it's got to be that. There's no way it's not. It's got to be that. And then we go through kind of step by step. You make a plan, do certain tests, and well, it's something else. And then kind of to swallow your pride and, oh, well, I was wrong. So that's why this failure analysis root cause process that the NTSB, FAA, Boeing, whoever, they're all going to go through their own versions of that to find a root cause for this. So curious to see what's revealed here.
decided to limit its operation over open water in case it turned into a larger issue with no emergency landing options nearby.
I guess that's better than nothing, but yeah, still, it's kind of like, well, maybe you should still get it checked out. But airlines are hurting for money, so it's a risk. You got to look at it as a risk mitigation cost analysis thing. So even though they thought, well, if it's just a pressure sensor that keeps resetting itself, you know, whatever. We'll exercise caution here, but had they known the severity of it, they should have grounded the plane and looked at it. But it's probably maybe a good thing that this is found, because just seeing headlines, it seems like there's some other ones that have been found. And it looked, I think earlier, United flights, some other planes had some loose bolts. So we'll see where this goes. Something goes wrong, and then, you know, it's like stink on poop. Everybody's on it ASAP.
So there appears to be some blame on Alaska Airlines and the regulations that allow them to simply turn off warning lights and assume that not flying over water will keep them safe. Someone could have easily died in this accident. It's a miracle no one near the door was pulled out.
That's true. If someone had got sucked out, it would have been a way bigger deal. Way bigger. And that warning light thing is kind of it's a hard line to toe. You can either be really binary about it, or you can be situational about it. So, oh, there's a warning light on, I'm not flying today, when it could be something super, super stupid or silly. And other times it can be serious. Exhibit A. So that's a tough one.
During the rapid depressurization. However, most people are pointing the finger at Boeing. This is not the first time the 737 MAX has had issues. Some of you may be familiar with the 737's previous issues, where new, higher bypass engines were installed. Higher bypass engines are much larger and much more efficient, but Boeing had a problem.
The higher bypass just basically means it can move more air. So there's a thing called a bypass ratio. And so the front fan of that, so there's a smaller, slimmer, like jet engine that you might see in like an F-18. That's a smaller tube jet engine, turbojet. And then, so this is a turbofan. So there's basically a giant propeller. That big fan is just it's not your traditional shape of a propeller. It's the bladed fan. And so the higher the bypass rate, because that's where it moves that's where it gets a lot of its power, is that larger fan up front. So if you have a bigger fan, more air through, higher bypass ratio, more thrust.
737 was too close to the ground, and they couldn't fit these new, higher efficiency engines under the wing without elongating the landing gear. So they figured out a way of attaching the new engines higher on the wing.
Interesting. Okay. So you're saying they couldn't make the landing gear taller, so they couldn't make the plane sit up higher. And I know where this is going. I think move the jets up higher. So now you're changing your torque on the aircraft now, because that jet engine is trying to escape to the left here, and it's pulling it along. So it's creating a moment or a torque. So F times L, force times length. That's your moment. So you're changing your moment about the length of the aircraft by moving your thing up. It'd be the same as a ratchet. You have your ratchet, and you move. Say this is your bolt end, and you're tightening a bolt. It'd be like moving your finger from here to here, or vice versa. So from here to here. So you have less torque on it. It takes more force, and you're not putting as much on. You get out here. Oh yeah, you can really get on it there. So that's what's happening here with the jet engine, basically.
To the point that the engine cowling is actually above the wing surface. This altered the stability and control of the aircraft, which caused the plane to be minorly unstable with a tendency for it to pitch upwards. A major redesign of the airframe to fix the issue would have required...
So I could be wrong about the moment, but I think it has both to do there. So there's the torque moment, and then there's the aerodynamics, like you said. So that coming up over the cowling, that made a low pressure zone, so that would actually increase lift, more or less. But I'm sure it sounds like it disturbed the aerodynamics in some manner.
Required recertification of the aircraft and retraining for the pilots. A time-consuming and costly endeavor that Boeing's executives wanted to avoid. So, they installed a software instead that automatically adjusted the plane's control surfaces to compensate for the new instability, which they called MCAS, a software that malfunctioned, causing the plane to nosedive on several occasions. In some cases, pilots were able to identify the cause and turn off the malfunctioning system. But on 2 of those occasions, Ethiopian Airlines Flight 302 and Lion Air Flight 610, the malfunctions caused crashes, killing a total of 346 people. All 737 MAXs were grounded in the aftermath of the crashes. Boeing's then CEO, Dennis Muhlenberg, was fired with a $62 million golden parachute. And Boeing...
Corporate America, man, I tell you. $62 million to get fired. I'd get fired for $62 million. You kidding me? It's freaking crazy. I'm curious to know how much he did or didn't have to do with that. It's kind of, I don't know. He must have said something. Because honestly, a CEO at that level, unless you're like Elon Musk or another CEO that actually knows what they're engineering, it's hard. I feel, be hard to hold that person accountable, because the CEOs of a lot of companies like this are just business majors. They don't know anything about the engineering, nor do they care. So it seems a little strange to just fire him, other than probably making it look good, and the public's like, oh yeah, they fired the CEO. Yeah, they're making change. Well, I don't know. I don't think that's the right answer, but we'll see. Maybe he did something nefarious.
Boeing paid $242 million in criminal fraud penalties, $1.77 billion in damages to airline customers, and $500 million to the victims of the crashes. These crashes deservedly damaged Boeing's reputation, showing that their executives were willing to take shortcuts to increase revenue. Although the severity of the issue is...
So if he was aware and making the decisions to make the shortcuts, I can understand that, I suppose. And yeah, wonder what those shortcuts might be. Maybe not. He'll get into them. I don't know.
Clearly not on the same scale. Many are joining the dots and seeing a pattern with Boeing's business practices over the past decade. Boeing recently requested that the FAA exempt the 737 MAX 7 from a safety regulation so they could deliver planes on time, as they worked on a long-term solution to an overheating problem with the engine. A problem which they asked the pilots to solve by limiting their use of the anti-ice system to just 5 minutes when flying in dry conditions, because the inlets around the engines get too hot and could fracture and strike the windows and cause a rapid decompression. Just like what happened to Southwest Flight 1380 when a 737NG suffered that exact fate, and a passenger was partially ejected from the plane and died as a result of her injuries. This was an older plane, which is not affected by this overheating issue, which is caused by the composite material cowlings, which is an issue exclusive to the 737 MAX.
Wait, so it was or wasn't related to what they were saying?
The passenger was partially ejected from the plane and died as a result of her injuries. This was an older plane, which is not affected by this overheating issue, which is caused by the composite material cowlings, which is an issue exclusive to the 737 MAX. But the potential loss of life is the same.
I don't get what he's saying there. So he said the composite material of the engine, I assume some portion of this gets too hot, or maybe, I don't know, let's listen to it again, see if I can make sense of it.
Could fracture and strike additions because the inlets around the engines get too hot, and could fracture and strike the windows and cause a rapid decompression.
Okay.
Just like what happened.
Okay, so it was the inlets. I was mistaking it for kind of the back end of the engine, so that's my bad there. So I can kind of, I guess, see both sides of this. The probability of that happening is low. It's all about risk. And similar to, they're probably frustrated with government regulation. So I think the latest example of that would be like Elon Musk and the Super Heavy, the Starship Super Heavy, the world's biggest rocket, which is probably launching in about 2 weeks again. But for the third test flight. But basically what happened with that is they did their first test flight, blew like a 50-foot hole through their concrete launch pad, separate issue. But then it got up, spun around, stuff malfunctioned, it blew up. And so then the FAA, they were ready to go, I think, in about 6 months. They launched in March. They were ready to go in like September. And the FAA kept delaying, and Fish and Wildlife too, because the government, so it took the government longer to have Fish and Wildlife make sure everything was okay, for them to completely basically reconstruct the rocket stand, build a new rocket, get it tested, and be ready. They were ready like 2 months ahead of the regulatory approval. So I can understand maybe there was some, it doesn't seem ill-advised in this case with the FAA because it's very strict, because you've got people's lives at risk. So I think it's just in that scenario. But maybe they saw it a different way, and it has extremely low risk. And it sounds like one aircraft out of, I mean, we hear about one death. Maybe it happened on more than one aircraft, but think of all the flights you see every day. Thousands of flights every day, and how many years it's over. That's extremely low. Not minimizing the severity of what happened, but I guess you could see it maybe from their perspective of minimized risk. It's not high risk in their eyes. But still, nonetheless, that's something that should be fixed.
Exclusive to the 737 MAX, but the potential loss of life is the same. To the recommendation of limiting anti-icing system operation to just 5 minutes, a representative of American Airlines pilots said, "We're not interested in seeing exemptions and accommodations that depend on human memory. There's just got to be a better way."
I agree with that. It kind of goes back to designing something for manufacturability, poka-yoking it, making it idiot-proof. When you're a pilot, just speaking from experience, if something goes wrong, it's like a high-stress situation. Like you're getting attacked, say, like an active shooter situation. It's all adrenaline. It just goes out your window. That's why you have checklists as a pilot. So you don't just go, duh. When your window blows out, you whip out your checklist, bing, bang, bong. You're talking back and forth, getting stuff done. And leaving that to memory out of the hundreds of thousands of pilots, that ain't gonna fly. Somebody's gonna forget something. We're just imperfect humans. That's just how it is. So you have to make it dummy proof, and the system wasn't. So
Loose bolts across multiple planes is a sign of a systemic issue once again. Something that should be easy.
Something with their quality. So what I said earlier about maybe it was a guy going to shift change, or I don't know. I'm just coming up with scenarios. clocked out for the end of the day and whatnot. So it seems like it's, like you said, a systemic issue, a repetitive issue, because they found it on, I guess, some more planes. Maybe he'll say how many. So that seems to be somewhat of a quality issue, something on their production line.
To add to a checklist and have a quality assurance inspector check it. However, in 2019, Boeing began laying off quality assurance inspectors in favor of so-called verification optimization, using less staff and more technology solutions. Reportedly, 900 inspectors were laid off over 2 years, a decision the Boeing Workers Union said was short-sighted without considering the long-term consequences. It turns out, it didn't take that long to see the consequences. Thankfully, no one died on this occasion, and it should be an easy issue to fix, but it just shines another light on Boeing's recent company culture. People claim this change in attitude is due to business executives leading an engineering company, but honestly, I think that's just self-congratulatory nonsense from engineers. Dennis Muhlenberg, the CEO during the 737 MAX crashes, was an engineer by training. Business majors do not have a monopoly on corporate greed. Engineers are perfectly capable of it too. Boeing has
True. Very true.
amazing engineers and produces amazing products. I have made an entire video gushing over the masterclass of design that is the 787. But there has been a systemic issue of prioritizing revenue and executive paychecks over customer.
Yeah, like the 50 or 60 some $1 million golden parachute to get fired. That's just ridiculous. I mean, come on, people.
Safety and employee job security. I think it's fair to say that a company with this much risk and responsibility over public safety needs more regulatory oversight, and asking for an exemption from a safety standard is a pretty clear sign that even the regulations that are in place are not being respected. Speaking of plugs, you can watch that entire 1 hour long 787 video ad-free on Nebula right now. Nebula is the home of YouTube's best aviation channel.
So it looks like that is the end. So let me know what you guys thought in the comments. I think this was really interesting and gets into the manufacturing in general, I think, and just weighing risk, yada yada yada. I wish there was a little more. Maybe it's still developing. This was posted 8 days ago. I don't know, why don't I pop on and try to find some articles real quick. So I wasn't able to really find anything new, noteworthy. So interesting to see maybe when this investigation wraps up, they find all the loose bolts in all the planes. See how many total. Maybe I'll make a video on revisiting that and kind of summarize it, and then we'll go into that maybe in a little more depth. So let me know if you guys like this. Drop a like, comment, and if you like the content, a sub would be much appreciated as well. Let me know your thoughts from the video, what you think happened, what you think about the whole situation, and what do you think, who's responsible here? Do you think Boeing's responsible? Do you think the CEOs? I think there's a kind of a shared burden, and just glad no one died from it, fortunately, which is good. But we did find an issue that could have killed somebody. So that's also good that, we're tightening up things, and there's a reason that we have the regulations. And so we're imperfect humans and crap happens. So that's going to be true for the designers as well. So, if you're an engineer, just do your best and double check yourself and get it peer reviewed. And that's standard design process anyway. So, yeah. Catch you guys next time in the next video, and have a good one. Peace.